Hi everybody. Today we're going to go through the steps to solve a simple parallel circuit. So I have a simple parallel circuit here with 3 resistors and a table for all my values. I'm going to start by going ahead and having some known values given to me. So I'm going to have that the voltage for this circuit is 12 volts. The value for the first resistor is 20 ohms. The second resistor is 10 ohms. And the third resistor is 40 ohms. So I can put this in the table down here, 20 ohms for the first resistor, 10 ohms for the second resistor, 40 ohms for the third resistor. In order to calculate the total, I'm going to use the fact that we have for parallel circuits, the total resistance is equal to the inverse of the sum of the inverses, which just means that we're going to add up the inverses of each of the resistors, 1 over 20 plus 1 over 10 plus 1 over 40. And then take the inverse of that. It's much easier with a scientific calculator. One thing that you can do is on Desmos. Here it is right here. If you go ahead and enter in on Desmos, it'll give you the answer right over here to the side. So this is Desmos Scientific, not Desmos Graphing Calculator. And it's pretty easy to put everything in and see that our answer here is about 5.7 ohms is our equivalent resistance. So going back to our table here, that means that that's going to appear, this will be equal to 5.7 ohms. And I'll put that down here. So we have all of our resistances. Now when we look at the other things that are going on, one of the key ideas is that in a parallel circuit, the voltage is the same in a simple parallel circuit. The voltage drop is the same across each of the resistors and the same as the battery voltage. That's the simple part. Sometimes if we have combinations of things, that might not happen. But for right now, all the voltage drops are the same. And again, thinking about why that happens, it has to do with the fact that the current is only going to be going through one resistor. So if it's going to come out of the 12-volt battery, it's either going to go through R1 here and back to the battery, or it's going to go through R2 and back to the battery, or through R3 and back to the battery. So it has to give all of its voltage to the one resistor that it goes through. So if we know our total voltage is 12 volts, that means that we can just fill in 12 volts for each one of the other resistors. So that's a key idea, that in parallel circuits, the voltage is all the same. In series circuits, the currents are all the same. So something to keep in mind as we're going through things here. All right, so now we just have to figure out what the currents are. And if we know we start with Ohm's law, V equals IR, we can divide both sides by R. There we go. So that we can get that current is equal to voltage over resistance. And we're going to do that for each of our individual things. Another thing to remember is that on the table, as soon as you have 2 of the variables in a line, you can figure out the third. Because V equals IR, as soon as you have 2 of those variables, you just calculate the third with Ohm's law. So for R1, we would say that the I1, the first current, is going to be equal to 12 divided by 20. And 12 divided by 20 is 0.6. Put that in my table. For R2, I2 is going to be the voltage divided by the resistance. 12 divided by 10, which is a nice easy one, 1.2. And it's not a coincidence that when you have half the resistance, you have twice the current, because it is proportional or inversely proportional. And then R3, to find the third current, we would take 12 divided by 40. Which comes out to be 0.3. And for the total, IT is going to be equal to 12 divided by 5.7. And I actually didn't do that ahead of time. We're going to get 2.1, and I'm rounding a little bit here. I've been trying to not make your, these are all in amps, trying to make sure that your Canvas problems don't have a lot of rounding in them to avoid difficulty. Now here, there is also a check that you can do. If you look right here, if you take all of the currents, they should add up. The currents through each individual resistor should add up to the total current. So if I take 0.6 plus 1.2 plus 0.3, I should get 2.1. And does that work? 0.8? Yep, works out, 2.1. And so that's a little check that all of my numbers work out well. All right, so hopefully this is helpful as you go on and do some practice problems. Take care.